Hi everybody, and welcome to our Hydrate Lab and our Hydrate and Empirical Formula Lab. This problem that I'm going to be going over with you is actually at the end of your notes. It's the last question in the notes. All right, and this is where we can actually figure out the formula of the hydrate using the mole. And what we're actually going to do is figure out how many water molecules are attached to your ionic compound. So let's read through. In the lab, a student heats a hydrate of calcium sulfite. The hydrate has a mass of 3.5 grams. After heating, the anhydrate has a mass of 2.41 grams. What is the formula of the hydrate? All right, so step one is you are going to write the formula. All right, so you're going to write the formula. All right, so what are we dealing with? We're dealing with calcium sulfite. Calcium is in group 2, so +2. Sulfite is a polyatomic ion with a -2 charge, so they come together 1 to 1. So that's going to be CaSO3, all right, because that's what sulfite is SO3. Okay, then there's a dot, remember, because that's how we attach our waters. Then there's a certain number of water molecules, and we don't know that number. Our goal is to figure out that number. So step 2, we're going to use the data to find grams of the anhydrate, and grams of the water. All right, so in here it says the hydrate. So this whole thing had a mass of 3.5. All right, after heating, the anhydrate had 2.41. So 3.5 is your total. And we'll put a 0 there just to make that look good. 2.41 is your anhydrate. And you subtract those to get 1.09, and that's your grams of water. So we're going to be using the mass of the anhydrate and the mass of water in step 3. So step 3 is we are going to go in ahead and change from grams to moles, and this is going to start to look like an empirical formula problem. All right, except for we're going to keep things as an entire compound. So I have 2.41 grams of anhydrate. Well, what's your anhydrate? It's just your ionic compound. It's just that calcium sulfite. So I'm going to put 2.41 grams of calcium sulfite, and then I have 1.09 grams of water. All right, great. I'm going to change my grams of calcium sulfite into moles. So in 1 mole, all right, and you're going to look on your periodic table. Feel free to pause, or you can just watch me going ahead. The mass of calcium sulfite is 120.2 grams. Again, I got that from the periodic table. Okay, you're going to stop there. I'm going to now change my grams to moles for water. Okay, and I should write CaSO3 up here just to make it look nice. And water has a molar mass of 18 grams. Okay, I'm now going to solve for the moles of each. So I'm going to take 2.41 divided by 120.2, and that gives you 0.02. I'm going to take 1.09 and divide it by 18, and that's going to give you 0.06. Okay, just like in an empirical formula problem, we're going to divide by the smallest. So we're going to divide each by 0.02. For these problems, for these hydrate problems, your ionic compound should always end up with 1, because the way we write the formula is for every 1 ionic compound, you get a certain number of waters. And in this case, you're going to have 3 waters. All right, so this gives us our final answer, 3H2O. And that is the formula of the hydrate. All right, fantastic. So your lab that you're going to be working on, and I'm just going to put that right here just so we can talk about it. All right, Molar ratio empirical formula lab. You have 2 pre-lab questions. Please make sure you're showing all of your work and doing your work in factor label. All right, you're then going to move on to the procedure. And as you're going to see in a minute, the procedure is exactly the same as the last hydrate lab that we did. We're using a different compound, but it is the same procedure. You're going to see Maurice mass the compound, then heat it with the Bunsen burner, let it cool down, and then remass. Okay? All right. Okay, so to give you some more details on this lab, on your lab sheet, they ask for the name of your hydrate, and the name of your hydrate is cobalt 2 chloride. And your cobalt 2 chloride, when it has the water attached, is this bright magenta color, all right? And you'll see that live when Maurice does it in just a minute. After you heat it up, you end up kind of with a periwinkle blue. The water has gone and you're left with this blue color. So it's very easy to see with our cobalt 2 chloride what the before and the after from when the water was there. So again, remember your goal is to come up with the formula of cobalt 2 chloride and then figure out from your data how many waters there should be. Since this is a lab, please realize that you might end up with a fraction. Here it might be, I'm going to make it up, 2.7 waters. For the lab, it's okay to leave it as a fraction, but please realize that for the pre-lab questions and the questions on the back, this really should end up as a whole number, all right? Again, in the lab, things don't always work perfectly, so this could end up as a fraction, but for any of the other problems we give you, that number of waters will be a whole number. Okay, enjoy the lab.
Hello, welcome to our lab. First, we mask the crucible. Then we add about 3 to 4 grams of our compound. It's about 2. There we go. That's about good.
Mm-hmm.
Next, we take the crucible and we put it on the Bunsen burner.
Very visible to see the water leaving this compound.
All right, we carefully put the crucible on the hot plate. For 5 minutes, let it cool. Now that it's cooled, we mass it with the water taken out.